Hello everyone and welcome to this video which explains the understanding of Ethernet. A local area network, the abbreviation LAN, is a common type of network that is found in home offices, small offices, and large enterprises. Understanding how a LAN operates, including network components, frames, Ethernet addresses, and operational characteristics, is important for an overall knowledge of network technology. This video describes a LAN and provides the fundamental knowledge about local area network characteristics, components, and functions. It also describes basic operation of Ethernet LAN and how frames are transmitted over it. The definition of a LAN. As a definition, a LAN is a network of computer and other components that are located relatively close together in a limited area. LANs can vary widely in their size. They consist of only two computers in a home offices or a small office, or it may include hundreds of computers in a large corporate office or multiple buildings. How are the components of LAN? Regardless the size of LAN requires these fundamental components for its operation. The first is computer. The computers serve as the endpoints in the network. They send and receive data. The next is interconnection. Interconnections allow data to travel from one point to another in the network. They include network interface cards, in abbreviation NIC, which translate data that is produced by the computer into a format that can be transmitted over the LAN. And network media, such as cables or wireless media, transmit signal from one device on the LAN to another. Next component is network device. A LAN requires the hubs, Ethernet switches, routers as network devices. The next component is protocols. Protocols are set of rules that govern data transmission over a LAN and include Ethernet, IP protocol, ARP, and reverse ARP, DHCP protocol. What are the functions of a LAN? It provides network users with this communication and resources function. The first function is access data and applications. When users are connected through a network, they can share files and software applications program. This feature makes data more easily available and promotes more efficient collaboration on work projects. The next function is resources. The resources that can be shared include input devices such as cameras and output devices such as printers. The next is communication path to other networks. If a resource is not available locally, the LAN, their gateway, can provide the connectivity to remote resources. An example is access to the web. How large is a LAN? A LAN can be configured in various sizes depending on the requirements of the environment in which it operates. A LAN can be small office, home office, which is SOHO. The SOHO environment typically has only a few computers and some peripherals such as printers. The second is enterprise. The enterprise environment may include many separate LANs in a large office building or in different buildings on corporate campus. In the enterprise environment, there may be hundreds of computers and peripherals in each LAN. Okay, let us see the Ethernet evolution. Ethernet is the most common type of LAN. It was originally developed in the 1970s by Digital Equipment Corporation, Intel, and Exelos, and was called DICS Ethernet. It later came to be called thick Ethernet because of the thickness of the cable that is used in this type of network. It transmitted data at 10 megabytes per second. The standard for Ethernet was outdated in 1980 to add more capabilities, and the new version of Ethernet was referred to as Ethernet version 2, also called Ethernet 2. The Institute of Electrical and Electronics Engineers, in abbreviation IEEE, is a professional organization that defines network standards. IEEE standards are the predominant LAN standards in the world today. In the mid-1980s, the IEEE work group defined new standards for Ethernet-like networks. The set of standards that they created was called Ethernet 802.3 and was based on carrier sense multiple access with collision detection process. Ethernet 802.3 specified the physical layer, which is layer 1, and the MAC position of the data link layer, which is layer 2. Today, this set of standards is most often referred to as simply Ethernet. A significant development that enhanced LAN performance was introduction of switches to replace hubs in Ethernet-based networks. This development closely corresponded with the development of 100-based fast Ethernet. The later introduction of full duplex communications has enabled the development of 1 gigabit per second after 10 gigabit per second Ethernet and beyond. Let us say now about LAN standard. Ethernet LAN standards specify cabling and signaling at the physical and the data link layers of the OSI model. This topic shows how LAN protocols map to the OSI reference model. The IEEE divides OSI data link layer into two separate sublayers. The first is Logical Link Control (LLC) and the MAC sublayer. The IEEE created the LLC sublayer to allow part of the data link layer to function independently from existing technology. This layer provides versatility in services to the network layer protocol that are above it, while communicating effectively with the variety of MAC and layer 1 technology growing. LLC sublayer participates in the encapsulation process. An LLC header tells the data link layer what to do with the packet when it receives a frame. For example, a host receives a frame and then looks in the frame header to understand that the packet is destined for IP protocol at the network layer. The second is MAC sublayer. The MAC sublayer processes physical media access. IEEE 802.3 MAC specification defines MAC address which uniquely identifies multiple devices at the data link layer. MAC sublayer maintains a table of MAC address of devices. To participate on the network, each device must have a unique MAC address. Let us see the Ethernet frame. In Ethernet technology, the container into which data is placed for transmission is called the frame. The frame contains header information, trailer information, and the actual data that is being transmitted. The fields that are in the MAC layer of the Ethernet frame include, firstly, preamble. This field consists of 30 bytes of alternating ones and zeros, which are used to synchronize the signal of the communicating computer. The second part, state of frame delimiter. This field contains bits that signal the receiving computer that the transmission of the actual frame is about to start and that any data that follows is part of the packet. The next is destination address. This field contains the address of the NIC of the local network to which the packet is being sent. The next is source address. This field contains the address of the NIC of the sending computer. The next is type or length. In the Ethernet 2 standard, this field contains a code that identifies the network layer protocol. In the 802.3 standard, this field specifies the length of the data field. The next is data and path. This field contains the data that is received from the network layer on the transmitting computer. This data is then sent to the same protocol on the destination computer. If the data is too short, a string of extraneous bits is used to pad the field to its minimum length of 46 bytes. The last is frame check sequence. This field includes checking mechanisms to ensure that the packet of the data has been transmitted without corruption. And what about Ethernet frame addressing? Communication in a network occurs in three ways: unicast, broadcast, and multicast. Ethernet frame addressed accordingly. In unicast transmission, there is just one sender and one receiver. Unicast transmission is the predominant form of transmission on lines and within the internet. The second is the multicast, communication in which information is sent to a specific group of devices or clients. In multicast transmission, clients must be members of a multicast group to receive the information. The third is broadcast. Broadcast type is a communication in which a frame is sent from one address to all other addresses. In this case, there is just one sender, but the information is sent to all of the connected receivers. Broadcast transmission is essential when sending the same message to all of the devices on the LAN. Let us say now about Ethernet addresses. The address that is used in an Ethernet LAN, which is associated with the network adapter, is the means by which data is directed to the proper receiving location. The address that is on the NIC is the MAC address, which is often referred to as the band-in address. Some vendors allow modification of this address to meet local needs. There are two components of 48-bit Ethernet MAC address, 24-bit organizational unique identifier identifies the manufacturer of the NIC card. The IEEE regulates assignment of the organizational unique identifier numbers. Within the organizational unique identifier, there are two bits that have meaning only when used in the destination address, which are broadcast or multicast bit. This bit indicates to the receiving interface that the frame is destined for all a group of end stations on the LAN segment. Locally administered address bit. Normally, the combination of organizational unique identifier and the 20-bit session address is universally unique. However, if the address is modified locally, this bit should be set. The second type is 24-bit vendor assigned end station address. This position uniquely identifies Ethernet hardware. How is the MAC address and the binary hexadecimal numbers? The MAC address plays a specific role in the function of an Ethernet LAN. The MAC sublayer of the OSI data link layer processes physical addressing issues. The physical address is a number hexadecimal format that is actually bound into NIC. This address is referred to as MAC address, and it is expressed as a group of hexadecimal digits that are organized in a pair or quads. Each device on a LAN must be a unique MAC address to participate in the network. The MAC address identifies the location of a specific computer on a LAN. Unlike other kind of addresses that are used in networks, the MAC address should not be changed unless there is some specific need. This is the end of the video. Thank you for watching and for your coming positive comments. If you are interested, subscribe.